asked to factor an expression completely or when solving an equation, it's possible that you could be using multiple factoring methods like GCF, difference of squares, trinomials. You could use 2 of them, possibly all 3. So the first thing you always want to try when factoring is to see if there's a greatest common factor, or GCF. In this case, if you look at these 2 terms, there is a GCF, and it would be -2. I say negative because if the leading term is negative, you always want to factor out the negative as well. So if we take out the -2, we're left with x squared minus 16 as the binomial. And now you want to look at those factors and see if they can go any further. So the -2, that can't be factored. But the x squared minus 16, you need to recognize that that is a difference of squares. So the -2 stays, and x squared minus 16 would factor to x plus 4, x minus 4. Then again, look at the new terms, the x plus 4, x minus 4. Those can't be factored any further because they're not difference of squares, and they're obviously not trinomials. So we have finished factoring this completely. We'd say it is prime right now. Can't be factored any further. Okay, let's look at another one. Okay, so here we have a trinomial. And before we try doing the split into 2 binomials, we first want to see if there's a GCF. And it looks like there is. I believe the GCF is 3. So if we take a 3 out, the remaining factor would be a 2x squared plus 11x plus 5. Okay, so now we have a trinomial left over, and it can possibly be factored into 2 binomials. Again, the 3 is finished, can't be factored any further. So let's try this. No 2. Put the 2 there. So 2x and x. And let's just try positive 5 and 1. If we do the loops, that's going to give me a 5x and a 2x, which does not add up to 11x. So that can't be right. So let's just switch it. Let's put the 1 here and the 5 here, and it looks like that'll work because there's 1x and 10x. So those add to 11x. So those would be my factors. And then we just want to check those factors one more time to see if they can go any further. 3 can't go further, 2x plus 1 can't go further, and x plus 5 can't go further. So we are prime now. We are fully factored. So again, the idea is look to see if there's a GCF, always, always, always. There may not be one, but you definitely need to check. And then once you're done with that, see if any of the remaining new factors can be factored any further. All right, so why don't you pause and try this one. And here's the answer.